want to talk about how to express a definite integral as the limit of a Riemann sum. So I have written out what you may have seen before, and that is on the left-hand side just a general formula for a definite integral, and then on the right the limit of a Riemann sum. And what I have on the right might not look like a Riemann sum at first, but when you think about it, this f of x times delta x, well, that's just giving you your height times your base, which is the area of a rectangle. And we can tell from this limit that we'll be doing that an infinite amount of times. And that actually is what a definite integral is, in the sum of an infinite amount of the area of an infinite amount of rectangles between two values. And so this isn't the actual proof, but to kind of justify why this actually holds true, I'm going to first define a definite integral. So I'm going to say the integral from 1 to 3 of x squared dx, and I want to basically write that as the limit of a Riemann sum. So first, I'm just going to sketch this integral. So if I draw the first quadrant, that would be what this parabola looks like. And I want to find the area under this parabola from 1 to 3. So this green shaded area is what I want to find. So first, let's take a look at this general formula for the limit of a Riemann sum. And you'll see there's a delta x component to it, and this is the base component. And so you might recall that the delta x, to solve for that, well, that's just b minus a divided by n. So let's do that. Let's do 3 minus 1 divided by n, which obviously simplifies to 2n. And so I'm just going to leave the n alone from now because this will actually be split up in infinite amount of times, but I'm going to leave it like this to eventually put it back into my Riemann sum. So now that we've taken care of the delta x, we're going to do the slightly harder but not too bad height. And so my height for this function is just, well, my function is f of x equals x squared, right? And so what this is telling me is that for every little base value, every x value, to get my y value, f of x, I square it. So for every little x value along the x-axis, to find my height, I just square it. And so what we need to think about is how we can write this in another way. So first, I want my height. Well, I know I'm going to be squaring the x value. And my first x value is 1. Okay? But you can't build up a rectangle from the point 1 comma 0. You can't build a rectangle from 1 and 1 squared. You need an actual distance to form a base, or else you don't have anything. And so I can't just write 1. What I can write, however, is, well, we found this 2 over n. That's the amount of rectangles I will be cutting this area up into. And so what I can say is that if I have 1 plus every little bit of distance that I accumulate, so every little 2 over n that I accumulate from I equals 1 to I equals n, and I square that, that's my height. Because when you think about it, it actually makes a lot of sense, because I can't just have 1, because a straight line, well, that's not a rectangle. It doesn't have any area, so that won't help us. But if I make an infinite amount of tiny distances between 1 and we build that up, and I get those along the x-axis, and then according to my function, I need to square them. So that's what I do. I square this. Then I will be getting the height of all of these rectangles. So this equals our height. I know I kind of changed colors in the middle, but hopefully that makes some sense as to how if we have our starting value, which in this case happens to be 1, and I'm adding a little bit of distance from 1 each time and I square that, then that will be giving me the height of all of these little segments. So now we're ready to actually put this definite integral in the form of a Riemann sum. So if I have the integral from 1 to 3 of x squared dx, well, I can say that that is equal to the limit as n goes to infinity of the sum from my this I value of the rectangle, and we do the sum of that from I is 1. So if this was 1 and 2, it's basically, well, n is going to infinity according to my limit, so it's basically 2 over 0 the first time, and then it just keeps getting bigger. And I do my height, which I just determined is 1 plus 2 divided by n times I squared, and then I multiply that by my base because a rectangle is base times height. Well, that is equal to the definite integral of x squared between 1 and 3. So I know this is a pretty abstract idea, but hopefully this gave it a bit of context, and even though this isn't an actual proof, hopefully you believe a little more that this is a true statement. Make sure you like and subscribe, and I'll see you in my next video.